Hello again. My name is Richard and welcome to my YouTube channel. Today, our discussion will still be on solving 2018-2019 Valley View University semester examination on Calculus 1. Last, we said that this particular examination was divided into two sections, Section A and Section B. In Section A, which carry 40 marks, students are supposed to answer all the questions there. I have a video where we solve the two questions at Section A. Please check it out on YouTube. Today, our discussion will be shifted to Section B, where we'll solve the question 3 and 4. And I will indulge you to check part 2 of this video, where we'll solve the 5, 6, and 7. This will be a very interesting engagement, so please watch the video till the end. So we'll start things off with the question 3A. But before that, did you subscribe to my YouTube channel yet? If no, please do. It is the only way you can help me grow my YouTube channel so that I'll record more mathematical content for you. So now we'll start with question 3A. They say if y is equal to e exponent 4x cos 3x, show that d square y over dx square minus 8 dy over dx plus 25y is equal to 0. So how do we solve this? So y is equal to e exponent 4x cos 3x. So these are two different functions multiplying each other. So to solve them, we use product rule. So what does product rule say? We keep cos 3x and differentiate e exponent 4x. Then plus. Now we keep e exponent 4x and differentiate cos 3x. So that's how we are going to go. So we have our first differential dy over dx will be equal to, I'm differentiating this, I'll get 4 e exponent 4x, then times our cos 3x, then plus. Now I'll keep my e exponent 4x and differentiate the cos 3x. So how do we differentiate this? You differentiate the angle 3, then you differentiate cos, which will be negative sign, then repeat the angle 3x. Please check out my videos on how to differentiate all this. So when we polish this, our dy over dx will be equal to 4 e exponent 4x cos 3x. Then this will be minus 3 e exponent 4x sin 3x. Now, because our proving contains second differential, so we need to find the second derivative of this function. So the second derivative, which is d square y over dx square. Let me rewrite this before we find the second derivative. So I can get 4 bracket e exponent 4x cos 3x minus 3 bracket e exponent 4x sin 3x. Now we can find our second derivative. Remember, this is still multiplying, so we'll use product rule. This is also multiplying, we'll use product rule. So our d square y over dx square will be equal to 4 bracket. So we keep our cos 3x and differentiate e exponent 4x. We get 4 e exponent 4x cos 3x plus, now keep our e exponent 4x and differentiate cos 3x. We get negative 3 sin 3x. Then minus 3. Now this, I'll keep my sin 3x and differentiate e exponent 4x. I'll get 4 e exponent 4x sin 3x. Then plus. Now keep my e exponent 4x and differentiate sin 3x. If I differentiate sin 3x, I'll get 3 cos 3x. Now let me polish this very well. So our d square y over dx square will be equal to 4 bracket 4 e exponent 4x cos 3x minus 3 e exponent 4x sin 3x. minus 3 bracket 4 e exponent 4x sine 3x plus 3 e exponent 4x cos 3x. Now I can expand. So I'll get this times this will give me 16 e exponent 4x cos 3x. Then this times this will be minus 12 e exponent 4x sine 3x. Then this will also be minus 12 e exponent 4x sine 3x. Then this will give us minus 9. So minus 9 e exponent 4x cos 3x. Now group items. So I'll get 16 e exponent 4x cos 3x. Then I have each item here to be minus 9 e exponent 4x cos 3x minus 12 e exponent 4x sine 3x, then minus 12 e exponent 4x sine 3x. Now, my d square y over dx square will be 16 minus 9. That will be 7. So we have 7 e exponent 4x cos 3x. Then minus 12 will be minus 24. So minus 24 e exponent 4x sine 3x. So now we know our second derivative, we know our first derivative, and we have the function itself. So please keep it in mind. So we've realized that y is equal to e exponent 4x cos 3x, and in dy over dx we have 4 e exponent 4x cos 3x. So we have e exponent 4x cos 3x. So in place of e exponent 4x cos 3x, we substitute y. Then we can say that our dy over dx is equal to 4, in place of this, y, minus 3 e exponent 4x sine 3x. Also, we have another e exponent 4x cos 3x in our second derivative. So we can say that our d square y over dx square is equal to 7y minus 24 e exponent 4x sine 3x. Now, I can make e exponent 4x sine 3x the subject here. So I'll bring this here and say, so I have 3 e exponent 4x sine 3x is equal to 4y minus dy over dx. I'll divide both sides by 3. So I'll get e exponent 4x sine 3x is equal to 1/3 4y minus dy over dx. That's dividing both sides by 3. So I realize that my e exponent 4x sine 3x is 1/3 4y minus dy over dx. I'll substitute it into the place of e exponent 4x sine 3x here. So I can say my d square y over dx square will be 7y minus 24 bracket 1/3 4y minus dy over dx. So what will I have? I'll have 7y. 24 times 1/3 will be 8, so minus 8 bracket 4y minus dy over dx. So this is my d square y over dx square. So I can expand this. So I will say my d square y over dx square will be 7y minus 8 times 4, that will be 32. So minus 32y, then plus 8 dy over dx. The negative times this negative will give you positive. So we can say that d square y over dx square is equal to 7 minus 32, that will be minus 25. So minus 25y plus 8 dy over dx. So you realize that in our proving, everything was equated to 0. So we need to bring everything here equated to 0. So we can say that our d square y over dx square, and this is positive, so we have minus 8 dy over dx, and this is negative, so plus 25y will be equal to 0 as required. So we have proved this. I hope you get that. We'll go to the B aspect of the question 3. So the B aspect of the question 3 states we should evaluate the integral cos cube s, then sine exponent 4s dx. And this is worth 7 marks. The A aspect was worth 13 good marks. That's how long it was. So we can rewrite this. That's the integral of cos cube x sine exponent 4x dx as the integral of sine exponent 4x cos cube x dx, which can be further written as the integral of sine exponent 4x cos square x cos x dx. That's when we multiply this cos x by cos square x, we'll get cos cube x. Why are we doing it? We are doing it because there is a relationship connecting sine and cos square, or sine square and cos square. And also when we differentiate sine x, we'll get cos x. So we can use integration by substitution to do that. So remember very well that sine square x plus cos square x is equal to 1. Very, very important. So we know that our cos square x is equal to 1 minus sine square x. So we'll let u to be equal to our sine x. So our du over dx will be equal to cos x. Remember that. Then we'll make du the subject. Du will be equal to cos x dx. So now in place of sine we substitute u. Then in place of cos square x, we substitute 1 minus sine square x. Then in place of cos x dx, we substitute du. So now let's go. So we know that the integral sine exponent 4x cos square x cos x dx will now be integral sine exponent 4x. Then in place of cos square, we substitute 1 minus sine square x, then cos x dx. Now our sine x is u, and our du is cos x dx. So we can say this will be integral u exponent 4 bracket 1 minus u square, then cos x dx will become du. So we have changed everything in the x system to u. Now we integrate this. So when we expand this, we'll get u exponent 4 minus u exponent 6 du. Now remember integration rule. To integrate this, you add 1 to the exponent and divide the function by the result. So we have u exponent 5 over 5 minus u exponent 7 over 7, then plus our constant of integration. But remember, u is equal to sine x. So we substitute back. So we have this will be sine exponent 5x over 5 minus sine exponent 7x over 7 plus c. So we can conclude that the integral of cos cube x sine exponent 4x dx will be sine exponent 5x over 5 minus sine exponent 7x over 7 plus our constant of integration. I hope you get this. So, the question 4 aspect, there are 3 questions there. And the A aspect of it is that we should evaluate the integral sine exponent 4x dx. Now, before you can do this very well, you need to know some trig identities, which are in double angles. That's the first one. That cos 2x, this is from double angle, is equal to 1 minus 2 sine square x. Very important. Also, cos 2x is equal to 2 cos square x minus 1. All these are from double angles. So we make sine square the subject. So we can bring this and send this. So we can say 2 sine square x will equal to 1 minus cos 2x. Then our sine square x will equal to 1 minus cos 2x all over 2. I divide both sides by 2. Also, this, we can make cos square as the subject. So we can say that our 2 cos square x will be equal to cos 2x plus 1. I brought the 1 here. I will divide both sides by 2. I can say cos square x is equal to cos 2x plus 1 all over 2. Now, since cos square x is equal to cos 2x plus 1 all over 2, then we can say that cos square 2x will be equal to cos 4x plus 1 all over 2. So this and this will play a very important part in we solving this question. So now, since we have gotten all the ingredients to make this question spicy, we can now solve it. So the sine exponent 4x dx can be rewritten as the integral of sine square x all square dx using indices. Or multiply this again, we'll get sine exponent 4 dx. Now we know sine square x is equal to 1 minus cos 2x, so we substitute. So we can say that this will be 1 minus cos 2x. Okay, please, in our first, there is over 2 there, if you remember very well. All over 2 all square dx. When we square this, we'll get the integral 1 minus cos 2x all square all over 4. That's 2 squared is 4. Now this is 1 over 4. I can bring it out, so I'll get 1/4 the integral of 1 minus cos 2x all square x. So we can expand this. We'll have 1/4 the integral of 1 minus cos 2x, another 1 minus cos 2x dx. So when we expand, we'll have 1/4 the integral of this times this will be 1. This times that will be minus cos 2x. Then this will be minus cos 2x. Then plus our cos square 2x dx. Cos 2x times cos 2x will give us cos square 2x. Now when we simplify this, we get 1/4 the integral of 1 minus cos 2x times minus cos 2x will give us minus 2 cos 2x, then plus cos squared 2x dx. So remember, our cos square 2x is cos 4x plus 1 all over 2. So we can substitute that one too. We get 1 over 4, the integral of 1 minus 2 cos 2x plus cos 4x plus 1 all over 2 dx. We can rewrite this again as 1 over 4, the integral 1 minus 2 cos 2x plus half cos 4x plus 1 dx. So now we integrate this 10 by 10. Integrate this 10 by 10. Remember, integration of cos, we'll differentiate this angle here. We'll get 2. Now when we integrate cos, we'll get sine and use the differential to divide the result. So what are we having? We'll have 1/4. The integral of 1 will be x. Remember that. Then minus 2. When we integrate this, when we integrate cos 2x, we'll get sine 2x over 2. Then plus half bracket. When we integrate cos 4x, we'll get sine 4x over 4. Then when we integrate 1, we'll get x. Then plus our constant of integration. Now this 1 over 4, we distribute it over this. So we get 1/4 x. Before that, you can get 1/4 x. These two can divide these two. So we get minus sine 2x. Then this times this, we get sine 4x over 8. Then this times this will be plus half x. Now we can distribute. So 1/4 times x will give us 1/4 x. 1/4 times this will be minus sine 2x over 4. Then 1/4 times that will be sine 4x over 32. 1/4 times half will be 1 over 8x. Then plus our constants. Now, these are like terms. We bring them together. So we get 1/4 x plus 1/8 x minus sine 2x over 4 plus sine 4x over 32, then plus our constants. 1/4 x plus 1/8 x will give us 3x over 8 minus sine 2x over 4 plus sine 4x over 32, then plus our constant of integration. So we can conclude that the integral of sine exponent 4x dx will be 3 over 8x minus sine 2x over 4 plus sine 4x over 32 plus our constants. I hope you get that. We'll go to the B aspect of the question 4. So the B aspect of the question 4, which is also worth 7 marks, says that we should evaluate the integral of e exponent x cos x dx. Now, look at it. When you differentiate cos x, you won't get e exponent x. And when you differentiate e exponent x, you won't get cos x. So you can't use integration by substitution. So you need to use integration by parts. What does integration by parts says? It says that you let u to be equal to this first function here, e exponent x, and let dv over dx will be equal to cos x, the second one. Now you differentiate this to get du over dx. And when we differentiate it, we still get e exponent x. Now to get v, we need to integrate this. So the integral of cos x will be sin x. Now from integration by part, it says that the integral of u dv over dx will be equal to uv minus the integral of v du over dx. Please, if you want to find out how this integration by parts came about, check out my videos on integration by parts on YouTube. So now we can substitute. So we can say that the integral of e exponent s cos x dx, which is this, will be equal to our u is e exponent x, and the v is sin x, minus the integral of v, which is sin x, then du over dx, which is also e exponent x dx. We can rewrite this very well as e exponent s cos x dx is equal to e exponent x sin x minus the integral of e exponent x sin x dx. So look at it. When we differentiate e exponent s, we will not get sin s. And when we differentiate sin s, we will not get e exponent s. So this is also another integration by part. So we pull this out and solve by part. After that, we substitute. So how do we solve this by part? The same approach. We let u to be equal to e exponent x and let dv over ds to be equal to sin x. Now we differentiate this. Our du over ds will still be e exponent x. Then to find v, we integrate this. So v will be equal to the integral of sin x will be negative cos x. Now remember integration by part, which says that the integral of u dv over dx will be equal to uv minus the integral of v du over dx. So we can say the integral of u, which is e exponent x, and dv over dx, which is sin x dx, will be equal to u, which is e exponent x, and v, which is negative cos x, minus the integral of v, negative cos x, then du over ds, e exponent x. So on polish this further, we can say that the integral of e exponent x sin x ds will be equal to negative e exponent s cos x, then this negative times this negative will give you positive, so plus e exponent s cos x. So now we know that the integral of e exponent s sin x ds is this. We now substitute in a place of e exponent x sin x ds. So we have pulled this and solved by part, and we had this. We now substitute. So we can say that the integral of e exponent s cos s ds will be equal to e exponent s sin x minus, so in place of this, we substitute this, minus e exponent s cos s plus the integral of e exponent s cos s dx. Now, in integration by part, we say that anytime you are solving by part and what you are integrating by part pops out again, there is no need to continue integrating by part. You just bring them together, then you simplify. So let's expand this bracket. We have e exponent s cos s ds will be equal to e exponent s sin s. Then this times this will be plus e exponent s cos s. Then this times this will be minus e exponent s the integral of e exponent s cos s ds. So these are like terms. We'll bring them together. So we have the integral of e exponent s cos s dx, then plus the integral of e exponent s cos s ds will be equal to e exponent s sin s plus e exponent s cos s. Now, these are like terms. So the integral of e exponent s cos s ds plus the integral of e exponent s cos s ds will just be 2 the integral of e exponent s cos s ds will be equal to e exponent s sin s plus e exponent s cos s. Then we divide both sides by 2, then we'll get our integral. When we divide both sides by 2, we'll get the integral of e exponent s cos s ds will be equal to e exponent s sin x plus e exponent s cos s all over 2, then plus our constant, which we can simplify as the integral of e exponent s cos s ds is equal to e exponent s is common to them, so e exponent x over 2, then bracket sin x plus cos s, then plus our constant of integration. I hope you get that. So the C aspect of the question 4, which is worth 6 marks. So we should evaluate the limit where x approaches 0 of 2 minus 2 cos 2x all over 12x squared. So in limit, when they ask you to evaluate a limit where x approaches 0, you just substitute 0 in place of x. However, when you realize that when you substitute 0 in place of x, and the denominator will be 0, making the function undefined, then you can't just substitute like that. You need to use what is known as L'Hopital to solve that. So using L'Hopital, what does L'Hopital say? It says that differentiate the numerator differently, differentiate the denominator differently, and now substitute the 0 or substitute the value of x. If it produces another undefined, differentiate your first differential again, the numerator differently and the denominator differently, then you substitute the value of the x. So now let's go. So if we have the limit where x approaches 0 of 2 minus 2 cos 2x over 12x squared. Now we'll differentiate the numerator differently. So we'll have the limit where x approaches 0 of, on differentiate 2, we'll get 0. On differentiate this, we'll get minus 4. Remember, we just differentiate 2x, the angle 2x, and use it to multiply this, we'll get minus 4. Then on differentiate cos, we get negative sine. Repeat the angle. That's it. Over, when we differentiate this, we'll get 24x. Let's polish this further. We'll get the limit where x approaches 0 of 4 sine 2x over 24x. Look at it. When we substitute 0 here, the denominator will still be 0, making it undefined. So we need to differentiate further again. So we can say that the limit of x approaches 0 will now be, now I want to differentiate this. Remember, we just differentiate the angle 2 and use it to multiply the 4, we'll get 8. Then when we differentiate sine, we'll get cos, then repeat the angle. So in that place, we'll get 8 sine 2x, 8 cos 2x, over, when we differentiate the 24x, we'll get 24. Now, the denominator doesn't have any variable, so when we substitute, we won't get 0. Now we can substitute. So we'll get 8 cos 2 times 0 over 24. We get 8 cos 0 over 24. Cos 0 is 1, so we have 8 times 1 over 24, which will be 8 over 24. And 8 into itself, 1. 8 into 24, 3. Then we can conclude that the limit where x approaches 0 of 2 minus 2 cos 2x all over 12x squared will be equal to 1/3. I hope you get that. So we'll end it here today by solving the section B of the 2018-2019 Valley View University Semester Examination on Calculus 1. I indulge you to check part 2 of this video on the section B, where we solve the question 5, 6, and 7. Until we meet again, please remember to subscribe to my YouTube channel. My name is Tete Jacob C. Richard.